methodologies for improving sediments management in urban stormwater systems. We have a really splendid committee for this. Thanks for the volume. I am hearing me better now. And I'm presenting for order of distance, so I'm part of the committee as well. So I'm not only chairing this, but I also was part of Maria Alejandra's committee. We also have Dr. Juan Pablo Rodriguez Sanchez from Universidad de los Andes here in Bogota, Dr. José Anta Álvarez from Universidad de La Coruña in La Coruña, Spain, and we also have Dr. Nicole Narot from Gdańsk University of Technology from Gdańsk in Poland. So for our committee online, so you are very welcome, very happy to have you here, and good day for you. Just to be sure that you are listening me properly, because you are the most important persons now, I just want from Jose and Nicole to confirm that you are having a good reception.
Yeah, I can hear you well.
Thank you, Jose. Good day for you.
Yeah, me too as well.
Great, Nicole. Thanks for your confirmation. So the procedure of this defense is pretty simple. Maria Alejandra will make a short presentation of her work for 30 minutes maximum. After that, we will have some questions from the evaluation committee. We will start from our external committee professors. Later will be, let's say, a session between them, and we will change opinions for at least, or let's say maximum, 1 hour and 20 minutes. I will give the word for each committee member for more or less 15 minutes. So the idea is to have 2 rounds of questions. So I will ask the committee members to have 2 or 3 questions in each session to have, let's say, the opportunity to listen everyone. After that, we will deliberate with the committee members. So we will be alone only here, and we will wait for the decision of this session. And we will end with the notification to Maria Alejandra of the final decision and the outcomes of this meeting. So this is mainly the procedure. I don't know if there is any question for the committee members, if everything is clear. Juan Pablo. Also from Jose and Nicole.
Everything is clear.
Thank you both. Great, thank you. So Maria Alejandra, we will start now. I will check the times. You will have 40 minutes. I will make you a wave when you have only 5 minutes left for you to know. So we are 9:12, and you can start when you are ready. If you want to share your screen now to put it ready to show the auditorium, and start when you are ready.
Good morning, everyone, and welcome to my presentation. First, let me thank you for all of you for being here today, especially to the evaluation committee members. My name is Maria Alejandra Pimiento, and I'm going to present my doctoral research titled Experimental and Statistical Modeling Methodologies for Improving Settled Sediments in Management in Urban Stormwater Systems, advised by PhD Andres Torres. My research concerns the sediments problem in urban drainage due to rapid urbanization and increase of impermeabilization of surfaces. The hydrologic cycle have been altered, increasing the stormwater runoff, which is a non-point source pollution, mainly to the sediment transport. All those particles can be discharged directly to the natural water bodies without any treatment promoting their contamination, or settled through the drainage system. So after a while, they must be dredged to avoid loss on the hydraulic capacity or floods. So this research proposed experimental and statistical modeling methodologies that allow management alternatives for sediment retained in urban stormwater systems. As management alternatives, I propose 3 levels based on available information. Level 1 is characterization. Level 2 helps decision making through risk assessment, which is calculated from level 1, and level 3 seeks to facilitate decision making using information from level 1 and level 2 as inputs. To define management alternatives, I analyzed sediments from 3 sampling points: Molinos River, the constructed wetland storage tank located here at the university, and Arzobispo River. All of them are located at Salitre Basin, which has the largest stormwater network in the city. I must say that it's not recommendable to extrapolate management alternatives or information from one sampling point to another. So I am going to focus on Molinos River, which is the site where I was able to collect the most samples. And the sampling point was located where the sediments accumulation was evidenced. I used handmade sediment traps, which were hung from a pedestrian bridge above the canal, and after 15 days of sediment recollection, they were removed. So as you may see in the table, a total of 25 samples were collected from March 2020 until October 2021. Now I am going to present level 1 management options for Molinos River. 3 major aspects should be considered on characterization: the basin, the hydrology, and the sediments. Regarding the basin, the area and land use must be defined. The map shows the basin for Molinos River, which is divided into 2 areas, rural and urban, with area about 1,689 hectares, from which 928 hectares correspond to the urban area. The predominant land use in the urban area is the residential. Precipitation and stormwater runoff should be calculated to characterize the hydrology. I use the downloadable information from the Bogota alert system. Different stations located in the city report the daily precipitation, and for the sampling point, I use the pluviometric station Gustavo Morales. Here, there is the precipitation for 2020 from the pluviometric station Gustavo Morales, and in red are the accumulation periods. So for each period, I calculate the precipitation height accumulation, the average intensity, and the maximum intensity. The accumulation period corresponds to the number of days of the sediment accumulation. Within these periods, there might be days with or without rain. And the antecedent dry weather period corresponds to the number of days before the first rain occurs during the accumulation period. To calculate the runoff, the curve number method was used. So according to the soil conditions of the basin, which is mainly composed with rose and hard surfaces, the curve number 2 is 90. And the wet and dry antecedent soil conditions were calculated using curve number 2. With this information, I calculate the maximum infiltration capacity and the runoff coefficient for each sampling period. For that, I consider the total rate in 5 antecedent days and whether it was a wet or dry season. Since we don't know how flow runoff information, we calculated with the rational method. Nevertheless, it used the precipitation information to calculate the flow. To characterize the sediments, the particle size distribution and the pollutants were measured. Regarding the particle size distribution, as you may see, Molinos River has the major particles are lower than 63 micrometers. And regarding the pollutants, we analyzed the polycyclic aromatic hydrocarbons and heavy metals. I must say that for the samples, all the polycyclic aromatic hydrocarbons are below the detection limit. So I'm focused on the common heavy metals in urban environments, which are cadmium, chromium, nickel, copper, lead, and zinc. We found high concentrations of copper and zinc, which are mainly associated to the wear of vehicle tires and brakes. On the other hand, I must say that only the 5% correspond to the soluble fraction of the heavy metal, so they remain adhered to the particles. With the sediment characterization, it's possible to establish reuse options in agriculture, soil restorations, slope stabilization, as a construction material or as a material for embankments. In Colombia, are specifications for the use of materials according to their characteristics, the chemical and physical characteristics. In accordance with the Colombian legislation, it is possible to reuse the Molinos River sediments in soil restoration or slopes stabilization and as a construction material. And regarding the particle size distribution, it is possible to use it in the core, foundation or as a cover soil in embankments. Now I am going to talk about risk assessment. It was made an environmental and human health risk assessment. The environmental risk helps to establish the source of the pollutants, their accumulation, and the sensitivity of the biological communities. I must say that from this slide forward, you may see on the right-hand side of the slide a table with the classification pollution, and on the left-hand side or center a bar plot with the results for Molinos River. So for the sediment quality guidelines, there are two values established: the threshold effect concentration, before which no adverse effects are expected. So as you may see on the plot, for at least 80% of the samples by cadmium, chromium, nickel, and lead are below this threshold, and the probable effect concentration above which adverse effects are expected. So only copper exceeds this limit. Other ways to assess the risk is through indexes. Some of them use the background concentration. Since there is no information, no local or regional information about background concentrations, we use the background concentrations in soils. So the accumulation index analyzes the natural fluctuations in the content of a certain substance in the environment. On the table, there are the classifications for this index, and Molinos River sediments are classified as unpolluted environment by cadmium, chromium, nickel, and lead, weakly polluted environment by zinc, and heavily polluted environment by copper. The enrichment factor helps to establish the source of the heavy metals, whether anthropogenic or natural. So according to this index, the cadmium and chromium concentrations are classified as deficiency to minimal enrichment, which means that it came from natural source, and copper as extreme enrichment, which means mainly from anthropogenic activities. For the other heavy metals, there are a variation between deficiency to extreme enrichment. The pollution index is the ratio between the measured concentration and the background concentration. There are only 3 classification levels. So for cadmium, chromium, nickel, and lead, there is a low level of pollution. For zinc, a medium level of pollution, and by copper, a high level of pollution. The modified pollution index uses enrichment factor and analyze all the heavy metals instead one by one. According to this index, the Molinos River sediments are classified as severely polluted, mainly to the copper concentrations. On the other hand, the pollution load index analyzes the cumulative pollution for all those heavy metals. And contrary to the previous index, the sediments are classified as unpolluted. The ecological risk index evaluates the sensitivity of the biological community to toxic substance. So according to this index, there is a low ecological risk. And finally, the modified ecological risk index use also the enrichment factor. So with this index, there is a variation between low and very high ecological risk. Regarding the human health, it was made with the workers in charge of dredging sediments and the people who live nearby to the disposal sites in mind. It was assessed by inadvertent exposure through 3 different pathways: ingestion, inhalation, and thermal contact. The risk of developing cancer was assessed for the common heavy metals that are associated with cancer, which are cadmium, chromium, and nickel. According to this, in adults, there will be a tolerable risk by nickel concentration due to inadvertent ingestion. Then for each path, the risk was evaluated cumulatively, and the total cancer risk is the sum of the three paths. So in adults, there will be a tolerable risk mainly to the ingestion of sediments. The same evaluation was made for children. In this case, there will be a high risk by nickel concentration for children to develop cancer. The total cancer risk also shows a high cancer risk due to inadvertent ingestion of sediments contaminated with nickel. For the level 2, the proposed management elements are based on the risk assessment. So I propose to develop a local sediment quality guidelines, since nowadays only some developed countries have developed them to preserve the streams. And the second is to define appropriate disposal options to prevent environmental damage. And the third is to establish a safe protocol to safeguard the health of the workers in charge of dredging sediments. Now I'm going to talk about level 3, which is statistical tools to analyze the variables determined in level 1 and level 2. With the statistical tools, the aim is to define significant inputs to reduce data collection and generate statistical prediction models. To define significant outputs to tests were applied. To identify if there is any relationship between dependent variables, which are accumulation and risk assessment, and with independent variables, which are hydrology and particle size distribution. The first test is the Cohen-Kappa coefficient, which determines the proportion of agreement between two categorical variables. The pairs of variables with a p-value lower than 0.05 were selected. On the left-hand side of the table, the dependent variables are listed, which are lead enrichment factor, nickel enrichment factor, zinc geoaccumulation index, and accumulation. All these risk variables are related with some particle size distribution variables and the accumulation with antecedent dry weather period. Simultaneously, the particle size distribution is related to precipitation height and average intensity, and ADP with D10, D20, and D30. In summary, lead enrichment factor, nickel enrichment factor, and zinc geoaccumulation index have a direct relationship with particle size distribution and indirect relationship with hydrology variables. And accumulation have a direct relationship with ADP and indirect with D10 to D30. So to continue with the analysis, it must be identified if the dependent variable is parametric or not parametric. We only found that lead enrichment factor is not parametric, so the Spearman correlation method should be used for this variable. Pearson correlation shows a negative correlation of 0.41 with a p-value lower than 0.05 between accumulation and antecedent dry weather period. A Spearman correlation shows a positive correlation between D20 lead enrichment factor and D20 to D60 about 0.6 with a p-value lower than 0.05, and with D70 a correlation about 0.5 with a p-value lower than 0.05. So considering the relationships found with the Cohen-Kappa coefficient and the sign of the correlation, limits were established. As you may see, when accumulation, it is expected that accumulation higher than 50% is appear to the canal when the antecedent dry weather period is lower than 0. And for zeta n zinc accumulation index, there will be a risk when particle size distribution have a lower value lower than the limit, and regarding the enrichment factor, there will be an enrichment when particles are higher than the established limit. So with this, it facilitates the decision making using freely downloadable information such as hydrological or easy to measure such as particle size distribution. Modeling tools were used to predict variables. Once the dependent and independent variables were defined, a linear regression model can be used if there is a correlation or otherwise other methodologies such as super vector machine can be evaluated. I propose a modeling methodology to predict variables applicable to any basin. Hence, I will present an application example using accumulation as dependent variables and ADP and D10 to the D30 as independent variables. For the model generation, two-thirds of the observation was used as calibration data and 1/3 of the observation was used as a validation data. A Monte Carlo method was applied with generating 1,000 combination of the validation and calibration data to avoid bias in the observation selection. Then I use the principal component analysis to rank the independent variables. So accumulation is represented by the component 3, and IDP is the independent variable with the higher influence on accumulation, and the 30 is the one with the lowest influence. To find the best model, all the kernels for super vector machine was analyzed, and all the independent variables were removed one by one from the list to the most influential. The best models will be the one with the small root mean square error for validation data. So for this example, for accumulation, we found an error of 36% using the ANOVA kernel and ADP, D20, and D10 as independent variables. In the graph, you may see in the box plot the variations of the 1,000 model generated, and in red, the measured data. I use the same variables to evaluate the multiple linear regression model. For the 1,000 models, the coefficient are represented in the equation, and with this model, we found an error of 50%. Despite this error, with this model is possible to detect outliers, which has an root mean square error above 1.5. And with this, we found 5 samples as outliers. Now I reevaluate the relationships between the variables, and the Cohen's kappa coefficients shows the same relationship for between accumulation and the independent variables, the same variables. But with the PCA, I found now, eliminating these outliers, that D10 is now the lowest influential variable. So with this configuration, once more I found that ANOVA kernel generates the lower error, and only using as ADP as independent variable, we found an error of 33%. We evaluate this model for 6 observations using the supervisor vector machine and ANOVA kernel and its independent variable ADP. So we found an accumulation higher than 50% only in one sample. Here I present the principal components from the methodology that could be applied in any basin to predict any dependent variable. Now, finally, I will present the management alternatives in multi-level approach. So for the management options, consider the reuse option. For that, I must know the heavy metal concentrations and the particle size distribution. For the decision making, risk assessment, to define disposal options of safe protocols for the workers should be defined, and the relationships between those variables helps to establish limit values as warning indicators and use modeling to predict those variables. For accumulation, according to the defined limit, there will be accumulation higher than 50% when no antecedent waiting period days exist. So when comparing with checking with the measured data, it is verified that the limit meet the condition, since for these samples there are 0 days ADPs, and we predict an accumulation higher than 50%. So for rainy seasons, high accumulation was expected, and under this condition, the dredging of the canal could be scheduled, having in mind the protocols to safeguard the health of the workers due to tolerable cancer risks. And regarding the geoaccumulation index by zinc, it was expected there would be a risk when it's higher than 1. It means that is from weakly polluted to extremely polluted. And we found those limits for D10, D20, D30, and D40. When comparing these limits with the measured value, we found that almost all the samples are below these limits, except these two. And we expected that taking these limits in mind, we are going to have an enrichment factor higher than G1. And when compared with the result, the calculated geoaccumulation index, we found that all of them are as weakly polluted. In terms of the reuse options, considering the particle size distribution and the heavy metal concentrations, for these samples, I can say this could be reused for soil restoration and construction. According to particle size distribution, only meet the condition to be reused as cover soil in embankments. As a conclusions, I found that the sediments particles are smaller, with a D50 around 110 micrometers. We analyzed the heavy metal concentration, finding that copper and zinc are have the greater concentrations, mainly came from anthropogenic origin and generate an environmental risk. Regarding to human health risk, and nickel concentrations generates a risk for human health, with high cancer risk in children by inadvertent ingestion and a tolerable cancer risk in adults by ingestion. As possible reuse options, the sediments could be used in soil restoration as a raw construction material and for embankments according to the particle size distribution in the core foundation and as a cover soil. The statistical tools helps to establish limits as a warning indicators, and we found accurate prediction models. At the end, I have to say that the analysis methodology that we propose in this thesis could be used at any point, and is not recommendable to extrapolate results of this methodology from one sampling point to another. As a future work, could be analyze the accumulation volume in the drainage, analyze other basins, analyze other sediment characteristics to comply with all the reuse options, and analyze the relationship between land use and heavy metal concentrations, measure the basin flow and stormwater runoff, and evaluate a cost-benefit evaluation for any of those, since it must be changed from one sampling point to another. I want to acknowledge to the Pontificia Universidad Javeriana, Ministerio de Ciencia, Tecnología e Innovación, Semillero de Agua en la Ciudad, and all of you that be around me during this journey. Thank you.
Well, Maria Alejandra, you did a splendid time. Thank you very much for